Today I'm going to go over the Chapter 14 Castlelearning review exercises in case you were absent today, or if you just want to review this again. Question number 1 gives you some information about angle and two sides, and it says the greatest number of distinct triangles that can be constructed. Well, when you have a question like this, it means that you're going to be setting up two ABC charts because you could potentially have two triangles that could be constructed. So I'm going to set up two ABC charts, and please do that also. And if you remember, we're going to put the given information in both boxes. So the triangle ABC, it says AB is 10, BC is 8, and angle A is 45 degrees. So that means little a is 8. So we're going to put that in both charts. It means little c is 10. Put that in both charts. And big A is 45. And put that in both charts. And so because we have a full row completed, we're just going to use the law of sines. Law of sines says 8 over the sine of 45 degrees is equal to 10 over the sine of c. So what we're going to do is we're going to do cross multiplying, and we're going to do the arc sine, or the inverse sine of 10 times the sine of 45 degrees divided by 8, and that'll give us the angle C that we need. So making sure that the mode is in degrees mode, we're going to do second sine. I use my fraction bar, 10 sine of 45 divided by 8. And that angle is 62 degrees. So 62 degrees is our quadrant 1 answer, but sine can also be positive in quadrant 2. This is a positive number. So in quadrant 2, our angle would be 180 minus that 62 degrees, which is 118 degrees. So in the first box, we put 62 degrees. In the second box, we put 118 degrees. This is quadrant 1, quadrant 2 box. And then if we add up those two angles, you get 107, and so there's still enough room to put an angle B, so we can create this one triangle. And when you add up 45 and 118, that sum is also less than 180, so you can create a second triangle. So the answer is the greatest number of distinct triangles is 2. You'll never get 3. It's either 0, 1, or 2, and in this case it's 2. Question number 2, they give you side, side, side information. And you can draw the triangle, which you should, and you'll see that angle A is across from little a. So if you want to try to find angle A, you're going to use that modified law of cosines. The modified law of cosines from your notes says that if you're trying to find big A, you start with little a. So we're going to do the inverse cos of a squared minus b squared minus c squared all over negative 2 times b times c. And that will give you the angle A. Because we started with little a, that will give us the big A. So just do second cos of, set up your fraction bar, 6 squared minus 7 squared minus 10 squared divided by negative 2 times 7 times 10. Make sure those last two numbers on the top are the numbers that you use on the bottom. And I have a syntax error. Oops, that should have been squared. All right, so the angle is 36.2 degrees because they wanted it to the nearest tenth of a degree. So that angle A is 36.2 degrees. So that's what you would put in the box. Part B says, find the area of triangle ABC. Well, if you look on your formula sheet has the area of a triangle in the upper left-hand corner. And the area of a triangle, right off from your reference sheet, is right here, 1/2 AB sine of C. Well, these letters, as long as they're all different, they can be jumbled up, rearranged. And for this question number 2, because we know angle A, we're going to use the area of a triangle as 1/2 times B times C times the sine of A, because that's the information we know. So area is 1/2 times B times C times the sine of big A. And that just goes in your calculator. 1/2, B was 7, C was 10, and the angle A we just found was 36.2 degrees. So when you put that in your calculators, 1/2 times 7 times 10 times the sine of that, I'm just going to pop up that answer that we got before. 20.7 is to the nearest tenth. That's the area of that triangle. Number 3. Number 3 has side information, and they want the largest angle. So the largest angle comes across from the largest side. Again, you have side information, so it's just like question number 2. And to find the largest angle, it's a law of cosines when you have side. So number 3 goes, you're going to do the inverse cos of 7 squared minus 3 squared minus 5 squared. These last two can go in any order, over -2 times 3 times 5. Those last two numbers are the ones that go in the denominator. And so we'll do an arc cosine of that fraction, and it's 7 squared minus 3 squared minus 5 squared, -2 times 3 times 5, and 120 degrees. Whoops, and 120 degrees would be your answer to that one. It would be option 3. Number 4, the forces question. When you have a forces question, it says 2 forces act on an object. So here are your 2 forces. And the first force has a magnitude of 85 pounds. They don't tell you which force it is, so I'll just put it on the bottom. And it makes an angle with the resultant. This is question number 4. Makes an angle with the resultant of 31.5. So we're going to draw in our resultant. And this angle is 31.5 degrees. And they say that the resultant is 130 pounds. So what we have is we have this triangle ABC down here. I'll label it ABC, which they're giving us little b, they're giving us little c, and we have big A. So when you set up your ABC chart, they give us big A is 31.5, they give us little b is 130, they give us little c is 85, and because you don't have a whole row filled out, it's the law of cosines. So they want us to find, it says find the magnitude, or to the nearest tenth of a pound, the magnitude of the second force. So this is the second force they want us to find, which is the same thing as the length of this line, which is the same thing as little a. So a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of 31.5. And so you put that all in your calculator and take the square root of it, and you'll find angle A, or side A. So I'm just going to start a square root right now. The square root of b squared plus c squared minus 2 times b times c times the cosine of 31.5 degrees, and that side is 72.67. That rounds up to 72.7. The answer to number 4. So to the nearest tenth of a pound, that would be 72.7. And remember, all of the answers are on the back here. 72.7, the answer to number 4. And then to the nearest tenth of a degree, the angle that the second force makes with the resultant. So when you take a look at this picture, here's the second force, here's the resultant. They want this angle right here. And this angle here is the same angle as this angle here, which is my angle C. So we're trying to find angle C. So with side A filled in as 72.7, we can use the law of sines, which says A over the sine of A is equal to C over the sine of C, law of sines. So when you do your cross multiplication to solve for C, you're going to do an inverse sine of 85 times the sine of 31.5, all divided by 72.7. And that'll go in your calculator. Arc sine of the fraction 85 sine of 31.5 divided by 72.7, and that would be 36.7 if you rounded that. Oops. 37.7 if you rounded that to the nearest tenth. So to the nearest tenth of a degree, 37.7 degrees. Number 5, you have some information given to you. For a triangle, you can draw the triangle if you want. ABC. AB is 14, AC is 20, and CAB is 49 degrees. So when you set up your ABC chart, you'll see that C is 14, B is 20, and angle A is 49 degrees. So setting up, so they want BC, which is little a. So this is a law of cosines question, side angle side, just like before. So a squared equals b squared plus c squared minus 2 times b times c times the cosine of 49 degrees. So we're going to do the square root of, because that's what a squared is, 20 squared plus 14 squared minus 2 times 20, excuse me, 49 degrees. And we got 15.1 to the nearest tenth, so we'd put 15.1 here. And to the nearest degree, angle C, well now we've got little a as 15.1, so if you want to get angle C, it would be 14 over the sine of C. Oops, I'll put that down here. C over the sine of C is equal to A over the sine of A. So when you cross multiply and do the arc sine, it's the arc sine of 14 sine of 49 divided by 15.1. It's arc sine because you don't know the angle. So second sine of the fraction 14 sine 49 over 15.1, and that angle is 44 to the nearest degree. It would be 44 degrees. So hopefully that matches up, and it does. 44 degrees. Number 6, 2 forces act on a body at an angle of 100 degrees. So we'll draw this question number 6, 100 degrees, force 1, force 2. And then create our parallelogram. And base angles of a parallelogram are supplementary, so that's 80 degrees. And the forces are 30 pounds and 40 pounds. And they want the magnitude of the resultant. The resultant goes up here. So if this is 40, or if this is 30, this is 30. So setting up our ABC chart, we'll see that we don't know what angle A is, but we do know that angle B is 80. We know that little a is 30. Little c is 40. We don't have a whole row filled in, so we use the law of cosines. B squared equals a squared plus c squared minus 2 times a times c times the cosine of big B. So we're going to do the square root of that whole thing in our calculator. The square root of 30 squared plus 40 squared minus 2 times 30 times 40 cosine of 80. And that would be 45.6. How do they want us to round it? To the nearest tenth of a pound, so 45.6. We go in here. and to the nearest degree the angle formed by the greater of the two forces. So the greater of the two is the 40. With the resultant, they want to know what this angle is, which is angle A. But we've just filled this in with a 45.6. So B over the sine of B, 45.6 over the sine of 80 is equal to, they want angle A, so it's 30 over the sine of angle A. Cross multiply, do your arc sine, 30 times the sine of 80 all over 45.6. Sine of 80 all over 45.6. It looks like it's 40 to the nearest degree, 40 degrees. Hopefully that's right. Yeah. So that's 40 degrees out of your calculator. Number 7. How many different triangles can be constructed? So when you have that, you know that there could possibly be 2. So you have 2 ABC charts set up here. And they say angle A is 125, so 125 goes in both. AB is 10, AB is little c. BC is 12, BC is little a. So the given information goes there, and now we're going to try to find angle C. So A over the sine of angle A is equal to C over the sine of angle C. So cross multiply and do your arc sine of 10 times the sine of 125 over 12. Let's see what that gives us. Second sine of 10 sine 125 over 12, 43 degrees. So angle C is equal to 43 degrees. That's our quadrant 1 angle, but we also have a quadrant 2 angle because sine is positive there, so we do 180 minus that answer. So that's 137 degrees. So we're going to put a 43 here, 137 here. And when you add up 125 plus 43, you get 168. So there's not enough room for an angle B here, but when you add those two up, you get more than 180, so you can't create a triangle there. So the answer is just one triangle. Number 8, parallelogram question. Two consecutive sides of a parallelogram are 6 and 4. So let's draw this parallelogram. 6 is the bigger one. 4 is the smaller one. The length of the longer diagonal is 9. Well, the longer diagonal is the one that goes from the acute angle to the acute angle, so that's 9. They're asking for the nearest degree to measure the largest angle of the parallelogram. Well, this is the largest angle, with the obtuse angle down there. So if we set up our ABC triangle down there, set up our chart to see what we have. We have little a is 4. We have little c is 6. And we have little b as 9. So we have side, side, side information. And they want us to find angle B. So if they want us to find angle B and you have side, 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 it's the modified law of cosines, which says b squared minus a squared minus c squared all over -2 times a times c is equal to the cosine of b. So if you just do a second cosine of that, second cosine of 9 squared minus 4 squared minus 6 squared all over -2 times 4 times 6. The angle is 127 degrees to the nearest degree they wanted. So 127. And hopefully that matches up. Yep. And the area of the parallelogram, well, the area of a triangle is 1/2. Now you know angle B here, it's 127. So the area is 1/2 AC sine of big B. All these letters have to be different, and since we know angle B from the previous problem, we're going to do that. Well, that's the area of a triangle. The whole parallelogram is 2 times that. So we're going to double that area that we get, and then we're going to get the area of the parallelogram. So 2 times 1/2 is just 1. So the area of the parallelogram is actually 2 times 1/2, which is 1, which is just A times C times the sine of big B. So A is 4, C is 6, and the sine of 127, the area of that whole parallelogram is 19 point, did they want it to the nearest square centimeters? 19. So 19 square centimeters. Number 9, they give us 2 angles. I'm going to fill in the third. 180 minus 70 minus 65 will give us that third angle, which is 45 degrees. So we have a 45-degree angle there. If you know 2 angles, fill in the third. To the nearest hundredth, the length of the opposite side of vertex A. So they want to know what little a is. So A over the sine of A is equal to B over the sine of B. That's the information we have there. So A is equal to 7 times the sine of 65 divided by the sine of 70. Don't forget to hit the sine button there. So, and we don't have to do an arc sine of that. It's just 7 times the sine of 65 over the sine of 70 degrees. So that's 6.75. They wanted to the nearest hundredth, which is 2 decimal places. So 6.75. And the area is 1/2. And what do we know here? We know that A is 6.75. So 1/2 A B sine of C is the area formula. So 1/2 times 6.75, B was 7, and angle C is 45 degrees. So 1/2 times 6.75 times 7 sine of 45 would be 16.7. They want it rounded to the nearest hundredth, so that 5 rounds that up to a 1, so 16.71. Number 10, we have 2 sides of a triangle which are 6 and 10. They form an angle that's 80 degrees, and we want to the nearest degree the measure of the smallest angle in the triangle. All right, well, first of all, we have to get this side down here. We can call this ABC if we want. So we want to know what little b is. So then we can find out what the 2 angles are. So b squared equals a squared plus c squared minus 2 times a times c times the cosine of big B. So I'm going to take the square root of that whole thing to find the side B. Square root of a squared plus b squared minus 2 times a times the cosine of 80. So that side is 18.731, or 10.731, I'm sorry. 10.731. So the smallest angle is across from the smallest side. The smallest side is 6. So we're trying to find angle C. So in order to find angle C, we do C over the sine of C is equal to B 10.731 over the sine of angle B. Cross multiply and do second sine. So you're going to do the arc sine of 6 times the sine of 80 over 10.731. and that should give us the smallest angle. Second sine of 6 sine of 80 over, and I'm just going to pop that answer up. Whoops, darn it. 6 sine of 80 divided by 10.731. That smallest angle is, to the nearest degree, is 33 degrees. And then the last question, equilateral triangle. Well, equilateral triangles have the same angles, 60, 60, and 60. And the sides are 10, it says. So angles of an equilateral triangle are always the same, they're always 60s. And what is the area of the garden? Well, area is 1/2 AB sine of C. So 1/2 times 10 times 10 times the sine of 60 degrees. Well, they want this in radical form. So 1/2 times 10 is 5. 5 times 10 is 50. And the sine of 60, that's one of those special ones. That's the square root of 3 over 2. I'm going to put a 1 underneath the 50. The 2 and the 50 reduce down to 25. So what I have left is 25 times the square root of 3. Remember, you got to remember about the sine of 60 degrees being the square root of 3 over 2. So the answer is option 2. And that's it. Good luck on your test.